thank you for joining us for this very interesting talk from Karen Lopez. First, I want to I'm joined here today with by our past president, Deborah Henderson, and our VP Online Content, Nick. And I guess before we get started, we have a couple announcements. We had a fantastically successful CDMP exam prep course last week, and it seems everyone had a great time. We've heard that folks have had some success with the exam as well. So we are looking to offer that again in the fall, and we will have more information for you the next time we join you, or the next time you join us, I suppose. We will be here. We also have some announcements about sponsors. So we have gotten some fantastic sponsors to help with technology and to support our efforts to bring you the format we currently bring you and new formats as well. Our first sponsor is First San Francisco Partners, a business advisory and data management consulting firm. You can see their website on the screen now. We also have a sponsor, our next sponsor, InfoSet, which will help small and medium-sized businesses extract value from their data and manage data assets. You can also see their website on the screen now. So thank you to our sponsors as well for letting us bring this to you. Now I'm going to pass it off to our past president, Deborah, to introduce Karen. That's not Deborah, that's my dog. Okay, go ahead, Deborah.
Thank you. Yeah, I was hoping I didn't sound like a dog today, but even though the weather is terrible outside. So thanks so much for that introduction. And I'm going to go ahead and introduce our speaker for today. Our speaker is Karen Lopez, someone who many of you will be familiar with. She is in Canada with us and is a data evangelist for Info Advisors. She's a space enthusiast and a NASA data nut. Karen is a senior project manager, architect with extensive background in development processes and information management. She specializes in taking practical approaches to systems development, and she has 20 plus years of public speaking, keynote speeches, and demos. And she wants her attendees to have fun and gain insights and take away inspiration for working with new technologies and methods. We'll be taking all kinds of questions throughout her session today. She's encouraging, interactive for sure. She's known for her slightly irreverent and practical approach to IT training. And she's an MVP for Microsoft worldwide. So she is more than qualified to talk to us today on the introduction to Azure, the MS platform for data professionals. We'll be looking at all aspects of Azure platform offerings, and topics included are a laundry list of topics and anything associated that you'll want to dive into. We'll wrap up with the ways data professionals can handle hands-on training and usage credits to earn on their own. So with so many topics to cover, we may cut topics based on audience interest. So thanks so much for joining us today, Karen, and all our attendees. And please, Karen, take it away.
Hey, get my screen shared. Oh, good. So I'm just going to leave my, I'm just going to try to wing this, because virtual presentations are a lot different than in-person ones. And what I mean by winging is I really want to encourage you to ask questions, offer commentary, say that I'm wrong, tell me that this is just hype, whatever you want to do. Because if I were there in person, that's what I would want you to do. So I'd like for you to do it now. And I won't be able to see your questions and comments, but we have Nick here who's going to help and make sure that I see them. And I have told him it's okay to interrupt me if he can get a word in edgewise. So this is going to be an introduction to some technology, data-related technologies in the Microsoft Azure Cloud Platform. The reason I picked these specific ones is they are also what's included in the most recent, or I should say the previous, Azure Data Engineer Associate certification that Microsoft offers. I'm also a Microsoft Data Platform MVP. So when you're a Microsoft MVP, that doesn't mean you're an expert in all the Microsoft technologies. What it does mean is that you have a lot of community contributions that you give back to the society and the tech world, and you do it about Microsoft stuff. I'm certainly experienced with other technologies, but because of this relationship I have with Microsoft, it enables me to do a lot more studying about their cloud offerings, as well as they provide cloud credits to me, which makes it a lot easier to learn about these technologies. And we'll talk at the end of this session about how you can get free credits as well. I'm also a Microsoft certified trainer. That means I offer training on the technologies. I often use the Microsoft official curriculum for those. And it also means I offer Azure Data Engineer Associate certification training. I happen to be a VMware V expert, as well as a NASA Datanaut. And that's the thing I like talking about the most. So the NASA Datanaut program is currently on a hiatus, like a lot of things in the world right now. But this was a program created by NASA that spun off their Space Apps Challenge Global Hackathon, which is the world's largest hackathon focused on using NASA and other space agency open data. I tend to tweet and talk a lot about the Space Apps Challenge. I'm a judge and a mentor in that program. And I would love to see many more data management professionals participate. Not all the challenges involve coding at all. There are even art-related challenges that happen. There are climate change challenges where you can propose ideas and strategies. It's a really great program. And if you'd like, you can participate with kids as long as they have an adult participating with them. The Canadian Space Agency also participates in the Space Apps Challenge, so you have the opportunity of working with Canadian open data as well. And if you ever want to contact me on Twitter about becoming a NASA Datanaut or participating in the Space Apps Challenge, I'd be happy to talk to you about that. One of the things is in my bio that Deborah read and on my slides, it says 20 plus years, but it's much more than that because I learned to stop counting at 20. So this session, we're going to cover a lot of technologies and solutions that are available in Azure. So you're going to get the top level introduction to these things. I want it to be more about the terminology, the architecture, what components they have, what features they offer for configuring or optimizing that makes it different than what we've done before. Excuse me. We'll see some architectures, which are just samples, not specifications. Microsoft has a lot of reference architectures available in Microsoft Docs. Those are really great to study if you really kind of want to figure out how all these things work together. This presentation is demo light. When I do training on these things, it's 4 days long or 3.5 days long, and that has lots of demos and labs, but this one won't. And then at the end, we're going to talk about how can you play with these things or get hands-on learning or even become certified in them. So I just wanted to, hold on. So one of the big differences between cloud and on-prem, I'm going to say on-prem because I know some people like to leave that S off the end of on-premises, but we data architects, we should always use the right term, right? So on-prem versus cloud technologies. So what's the big difference here? And this applies to all cloud offerings, no matter who offers them, Microsoft or Azure or Google or IBM or Oracle, whatever you're using, is that the computing environment that's offered is something that you don't have to go through a 6 months of acquisition process to get a server to run your data model repository on. It's just something that you spin up. You can do it very cheaply. You can do it very expensively. And I'll be talking about some of those things. The best thing that I find about working in the cloud is the licensing model. So your per minute, per gigabyte, per compute, per cluster pricing often includes all the licensing that you need to do. So it's all bundled together with the hardware, the network, the security, the monitoring, everything that you need to do along with the licenses. So the days of having to speak to a salesperson in order to get a trial license and try to get it for longer than 3 days are really gone in this model. So I reflect back on this to the early days of my career. So pre-client server, I didn't have a mainframe in my basement. So the only way to learn how to work with brand new relational databases was to get access to somebody's mainframe or time sharing environment. Then as client server came on, we could download an evaluation version of SQL Server or DB2 or Oracle, but you still normally had to speak through the sales process in order to do that. Maintainability is an interesting thing because you don't maintain the underlying technology. The cloud provider does. That's both a blessing and a curse. What I love about it is I no longer have to beg management to upgrade to the newest model in order to get access to new features. They're just going to be there. The trade-off is the cloud providers have learned they can't really break older versions with a new version, because once you do that, you're causing people an outage. So they have to have non-breaking changes. And one of the differences it has made specifically in the SQL Server world is that while features are deprecated, they've already said they aren't going away. So some features that have been deprecated for more than 10 years are still available. You can still use them. You shouldn't still be using them. You should be using whatever modern replacement it had. Scalability is also a big thing in the cloud. That's that you can throw a bunch of new hardware or what looks like hardware at a problem when you have blippy workloads. That's my favorite, because in the past, we had to do a whole bunch of capacity planning up front to buy a large enough server to get us through whatever our server refresh time was, which was often years, many years. And then the high availability is almost, this is the cloud story, is yes, we used to get a repository server for our data modeling tool, but we didn't get 4 of them so that we could have failovers. We got 1. And then we went to virtual machines, and probably your repository or your data management tools, your portals, your catalogs, your metadata tools, probably run in VMs, and now you can get failover to those things. But not every business wants to pay for high availability for what they consider developer tools, even though our developer, our design, our modeling tools are our production, right? So if our modeling tools are down, or the license server for our modeling tool is down, we're down in most of what we can do. So those are the bigger differences. The one other thing that I think is a big deal is that we went from not really having to worry about how big a database was or how big our storage was, because the companies invested up front and it was relatively free to us. Now, storing things in the cloud, which is really cheap, it still has a per byte cost. And especially for things like very large databases, very large file systems, there's a per byte cost. So it's like if we had to go back to paying per minute on the telephone or per minute for our internet connection.
Karen, question.
Yep, sure.
When we talk about scalability and it being rather automatic, and then you add in the per byte cost, you know, certainly the contracts are going to be interesting in that up front you'll have to take in, you know, that risk or that additional cost factor instead of, you know, waiting internally for, you know, 6 months a year for the money to be available. So it's a different kind of monetary risk, let's call it, from a purchaser point of view.
It is, certainly. And cloud costing is something, kind of a job that came back. It's just got a new name. So, when I worked at very large enterprises, we would hire outside capacity planning consultants to help us for every new application we deployed, because we had to basically do big upfront costs in order to support our needs for the next 2 or 3 years or 5 years. With the cloud, that's now inverted. So it's very inexpensive at times to get started in the cloud. But if you don't go back to monitoring every use and alerting on big uses, it's easy to run up a giant bill. So I mentioned in the introduction that Microsoft gives me a pot of Azure credits, and it's quite a bit. Like, it's a lot of money's worth of credits. So Microsoft does their credits according to your local currency. So Canadian dollars, US dollars. And I get a lot to do my training and to do my public speaking. But some of these things, like if I start up a very large data warehouse with 60 nodes, anytime you have a cluster of compute, it's easy to run through thousands and thousands of dollars of credits in a day.
So it would also include or encourage people to manage their space more.
Yes.
And you know how test databases and UAT and SAT databases can get out of control. So that's really interesting that practice, which everybody's ignored for many, many years, is come back.
It has
with
come
this
back.
monetary model, right?
Right. And it's a cost benefit risk, as you alluded to. And definitely the barrier to entry is very small now, right? I don't have to have someone buy a server. I don't have to agree to license software. I'm just paying, like I said, a bit and a byte. And we'll talk a little bit how things are priced as we go through this. But it's definitely also the new sort of profession that's come about is specialists who will come in. So they used to have these for your long distance bills at enterprises. Someone will come in, look at your cloud bills, and make recommendations on how to reduce them. They'll look at databases that nobody's using, storage accounts that haven't been accessed for 2 years, clusters that might be over provisioned, clusters that are under provisioned and therefore causing unplanned outages. All of those things they'll do, and then they take a cut of the savings. So that used to be a profession in the long distance world or in the mobile devices world. So it's just a new way of monitoring your costs. So really good question there, Deborah. So the first thing we're going to start with is Azure Storage. Now, I work with a lot of storage people, especially in the influencer world, and storage has never been my thing. I certainly like having my multi-terabyte storage devices in my own office, but in the enterprise, it was always someone else who did it. But the core to every cloud thing that you provision, if it involves data, has to involve storage. So we talk about those. Now, Azure Storage has a lot more features, a lot more types. I'm just going to focus on storage blobs and Azure Data Lake storage because that's what's used by the rest of the data platform. It's the foundation of all things data. It's affordable because it's not that storage is free, but that my Azure bills, because I don't have petabytes of data or even terabytes. I don't think I have up there. It's something I barely manage. Now, where this could get expensive is some of the configurations that you can take advantage of. So Blob Storage has access tiers. It has hot. So that's regular storage. Like that's for your online stuff. It's data that's frequently accessed and it has the highest cost of storage. All the cloud providers right now talk about how ingress, putting data into the cloud, is free. But with storage and with cloud solutions, you pay for data as it's stored, as it's persisted, and then data you take out of the cloud. Data that stays in the cloud, you're just paying for the storage. Data that you bring out, say to on-prem or onto a desktop, that's you pay for both things, egress and storage. Then there's cool storage, which is infrequently accessed. It costs less, but you only get that discount if you don't access it for 30 days or more. Archive is really cold storage. It takes longer to get to it. It's the cheapest, and it is priced so that you don't use it for 180 days. So let's look at a typical use case for here. My database is going to be stored on hot storage because I need it to be the fastest, premium storage, solid state devices, big compute, all of those things, because I need performance and high availability and all those things. That's the highest cost. But I might take a backup every day. And I might put that backup in hot for a week, and then I might move it to cool for a month. And then after that, if I have a statutory reason to keep backups for longer than 30 days, and due to ransomware, you should leave backups, keep backups for longer than 30 days, then I might put it in archive. Now, if I have to go get it after a week in archive, yeah, I can still go get it, but I'm going to pay more. I'm going to pay, it's not really a penalty, but I'm going to pay the higher price because I wasn't using it as an archive to store things for longer than 6 months. And the reason I went into that detail there is because a lot of the configuration that you do in the cloud, because it's per minute or per gigabyte or per compute, we have, as architects, we need to be able to specify those things, because all of those is a business decision, because it has to do with cost, benefit, and risk. Now, the other thing that's interesting to most cloud is how does it provide availability? So, and this is usually done through replication or a distribution or a combination of both. The terminology is a little bit different by offering, but blob storage and data lake storage, which we'll talk about in a second, breaks down into these different offerings. So locally redundant storage, it means that the copies of your data are stored in the same scale unit. A scale unit is something that shares the same power sources, the same network, often the same facility, definitely the same facility. Think of it as like a rack in a data center. It might not be in the same rack, but if power goes out to that data center, all your copies are unavailable. It's the least expensive because of that. And it has a whole bunch of those are 11 nines of durability, which means that the chances of you losing that data, losing it, is really low. Not having access to it because a region is out, or that rack died, or the power supply for it died, is it's still rare, but it's the most risky way to store your data. I use locally redundant storage all the time because I'm doing demos and I'm playing or learning, and I don't have any real data in there, so it's the cheapest. That's what I do. Zone redundant storage is data in the same region, but across 3 physically separate clusters that don't share the same power supply, don't share it, but they're all together in the same zone in the same region. Then geo-redundant storage allows you to go across. So a region, there's like Canada East, Canada Central, Eastern US, like these are big regions. Geo-redundant means exactly that. If a whole region were to go out, you're still going to have access to your data because your copies are spread across multiple regions. That is 16 nines, because I'm not going to count them. I have to put it in my notes. And then read access geo-redundant is the same as geo-redundant, but you're going to allow people in those other regions or anywhere else to actually read that data. If you just do geo-redundant, you will fail over to it. If you do read access geo-redundant, then you can also solve the physics problem of the cloud, that people can access data that's closer to them. And you can see how the expense goes across all of those. So we go from left to right to more expensive, but more available. And we'll see that kind of geo-replication concept apply to a lot of these things. So blob storage is just that. For me, you have a storage, you have a subscription, a storage account, a container, which is like a folder. Like if you go browse through these in Windows Explorer or Data Explorer, it looks just like, you know, your hard drive folder system. And blobs just mean a file, and it's a whole file and managed as a whole file. This is blob storage is used. There's block storage, there's other types of storage in Azure, but data solutions tend to use this. And then there's Azure Data Lake Storage, which is a flavor of blob storage. So it's based on blob storage, but the storage itself is optimized for big data and analytics, which is also a key word for being compatible with Hadoop distributed file systems. And the most important thing Microsoft would like you to know about this is it supports a truly hierarchical namespace. So if you've used Hadoop in like a pure Hadoop distributed file store system, you know, in order to get this folder-like hierarchy in it, you just name the files like this, like region/customer/department/order/month. But in Azure Data Lake Storage, that actual hierarchy, which looks like folders to most of us, is actually physically there. That benefits you because now you can process things in a folder in a hierarchy one at a time. So just this month, without having to read all the other names of the files with a pretend hierarchy to it. So did anyone have any questions about storage? Okay. So maybe you're like me. It's just a foundation, and I know storage people are really excited about storage, but it's not my thing. So the next data platform feature is Azure Databricks. So Azure Databricks is an open source system that's available out there. It's based on Spark, Apache Spark, and it does a little bit of ETL, ELT, and analytic workloads. Azure Databricks is Microsoft's implementation of Databricks as a service. So you don't install the Databricks, you just spin it up. So why might you do that? So Databricks is optimized for processing data. So there's streaming data, processing data, there's transforming data, there's storing data. This is focused on streaming and processing data. It's Azure Data, it's Databricks as a service. So Microsoft manages all of the compute and network and storage for it. You just have to configure those things. Enterprise security is done via Azure Active Directory. So it's like Active Directory, it's just hosted in the cloud instead of in your own local Active Directory. There are enterprise service level agreements for this. And it's also integrated with all the other Azure data stores, which we'll be talking about, along with Power BI. So the components of it, so everything in the cloud that originally wasn't relational is now has a relational layer to it. And this concept of cloud compute, open source and modern processing, it's not just cloud, but modern processing, to put structured query language on top of a non-relational feature is something that came about because newer technologies that didn't support SQL or have, I should say SQL in this case, because it's not SQL Server, it's just a structured query language, a form of it, that they were having slow adoption in enterprises because enterprise developers, management didn't want to have enterprise developers have to learn every single query language that was out there. So if projects put SQL-like, SQL-like queries on top of it, an average relational database developer could easily take up working with data and those things. So in Azure Databricks, it's Spark SQL and data frames. And data frames are a collection of named columns that appear in a table. So in your mind, if you're not familiar with data frames is just data presented as if it were in a table. Databricks is primarily about real-time processing of streaming data. We're going to talk about another offering that also offers streaming data. There's a machine learning library, there's graphs and graph processing, and then there are the languages that you can use to develop your solution with, like R, SQL, Scala, Java, and Python. These are the big development languages. So when you provision Azure Databricks, you provision a workspace, and the workspace kind of looks like this screenshot on the right. All your things that you build organize into folders. It's totally web-based. There's some dashboard stuff. Because it's based on an open source project, one of the great things is that there are all kinds of libraries of code, of runtime packages, things that you can link into that support those languages of Python and R and all of those things. And you can run experiments for machine learning. So I don't know how many of you have used any type of notebook technology. I think it is the best thing since sliced bread because it allows me to work with code, with comments, with pictures, and see the output all in one place. So in this particular example, at the top, just under Data Notebook, there's a cell that has some Python code there. It's for specifying, please make this data frame for me from this source. And you can see, I want the top 10 rows from something called source that I've defined above, and it's limiting it to 10. And that is the data frame output. The output of the Spark job is now I've got this data frame sitting there, and you can see it looks like a table. But I want to draw your attention to one of the other nifty things about working with notebooks in general is they have these things. So you can see where the green circle is, that there's a little graph there. And if you click on it with your data frame, it immediately turns it into a plot or a graphic. So it's the same command. You've just clicked on something and said, please display this in a bar chart. And then you can click on the plot options and say, no, make it a line chart, label the, all the things that you can do with charts in general in order to do this. Notebooks have a lot more functionality. And one of the interesting things about Databricks notebooks is they have like a small set of all the features that some more prominent notebooks have, like Jupyter notebooks or Azure notebooks, but it allows you to make these notebooks and you're saving your query, your comments, interaction with it, all in this same interactive environment. And you can share them with other people. You can post them. You can edit them. It's a really neat way of working with command line interfaces without feeling like you just did time travel back into the late 80s.
Good question, Kara.
Yeah.
So with regards to the data frame, you're working with unstructured and structured data.
Yep.
How does the data frame make its decision to present it as columns to you? Is it machine learning, AI? How does that work?
No. So somewhere up above in this, when you define a connection to data, you can apply this schema to it. So somewhere above some command I ran, you can see in the cell that's just under team data cluster there with the green dot, I've kind of defined that the data frame has this data type string, something called, you can see those same headers across my data frame. So if this was, I believe this particular source was a comma delimited thing. So all I had to do is specify in order of the columns what they should be called and what their data type really was in order to do this. The good thing about it is there's a big debate about what structured and unstructured data means. Some people believe that relational database means structured and everything else is unstructured. I don't quite fit in that category. But the good thing is, if this were just a length delimited data file or a space or a tab delimited, like there's all these JSON, no matter what it is, I get to decide that schema at the time I'm reading it. So I specified that schema when I read it.
I see. So in this example, it was all hash delimited or comma delimited. So you had to refer to the columns in the order in which they were in the file. So
Right.
you could skip ones if you wanted to.
Yeah.
What if something was a blob? You could somehow specify that to come in as well?
I believe so. I mean, most of the non-relational things I work with don't have blobs in data files as much, but this definitely is, I'm sure there's a solution for that somewhere. And there really is, like, I could also have presented the columns itself in a different order than they were in the underlying thing. I could also, between defining the frame, I could also transform it and do calculations, or change it from 1 and 0 to true and false. Like anything you can do during this processing.
Sure, and it's all based on SQL.
The query is, there are other ways to work in notebooks. You can work in, like, this is Python with the SQL language on top of it, but I could use R or Scala or any of those other languages that this particular thing supports.
Great, thank you.
So we got one question is a clarifying one. This is the Databricks notebook, right? It comes with the Azure platform. Okay, cool.
Yeah, and it comes with Databricks as well.
It comes with Databricks as well. And someone else was asking if there's like a free tier to Azure or just to Databricks itself, or like a testing or something like that.
So I'm going to talk about that at the end of all of this, but the answer is yes.
Wonderful. Someone in chat will be happy about that.
With reservations, of course.
And the final one is, someone is asking, can you describe some of the intertwining that occurs between using Databricks notebooks with or without Synapse?
Synapse? Is that?
Synapse. Sorry, that's the correct one. Yes.
Some people say it both ways. I just want to make sure I understood that. So when we talk about Synapse, which is one of our modules, I will definitely address that. But definitely they integrate.
Wonderful.
We'll talk about that.
Thank you so much.
So that was a really brief thing. Like I said, there's so much more to learn about Databricks. And I just want to pause here for a second and put a very good, I'll try to show this at the end, but a really good plugin. Like okay, so I'm going to guess that most of us attending this event have more than a couple of years experience working with data and data platforms. Microsoft Docs, like the official documentation for all of Microsoft products, but specifically Azure, I'd have to say is really good. My primary starting to learn and work with a product in Azure, I actually start with the docs. And they are reference docs. So they're not like, like buying a book on things, but almost all the technologies under Microsoft have tutorials, how-tos, samples, all kinds of things. Like for instance, if I want to play with something that uses streaming data, I don't have any streaming data. I guess my tweets is the closest thing I have to streaming data in my world. But I can go through Docs and download a little pretend telemetry engine that sends car event metrics streaming into one of these services. And it's just pushing data. I can go do that because it's in the docs along with a step-by-step guide. So that's where I start. There's formal training and other things. But all throughout, I just don't avoid docs because a lot of us learned after you stopped getting a manual with everything, you stopped trying to use system documentation because it was so bad. Well, one of the reasons why Microsoft's documentation is so much better is they manage it all on GitHub. So anybody who spots an error or something that's out of date, they can go and either do a pull request and fix it and push it back to the project owners, or you can just log an issue in order to be able to do that. So the docs are just getting better and better and better. So the next thing, oh my gosh, I could spend the whole time talking about Cosmos DB. So Cosmos DB is one of my favorite Azure things because it is a new database technology that was built from the ground up just for the cloud. So unlike, as we'll talk about, Azure SQL, which is kind of Azure's is a SQL database that now runs in the cloud as a service, Cosmos was designed from the beginning to run in the cloud. It is a multi-model database as a service. And by multi-model, I mean it's a graph database. It's a SQL-like database. It's a column family database. It's all of those databases all together in a service. It's globally distributed, like designed to be globally distributed. It's highly available. They have guaranteed SLAs for both availability and latency. And I'm also a space enthusiast, as you can tell. So I'm just happy with this name. So we talk about the APIs. This isn't about programming. These are the models. So the core model for Cosmos DB, you connect, you design it and connect to it and talk to it in SQL. The graph database API, you design and connect to it with a graph language called Gremlin. For key values, there's an API called Table. For document databases, you use the MongoDB languages and connections to it. And for column family, it's like Cassandra. This originally started as Document DB. And then as they added different models to it, now it became Cosmos DB.
Sorry to interject. Yeah. One other question, unfortunately going back to Databricks.
That's okay.
But someone's asking, can we connect Databricks output directly to Power BI?
I believe so, but that's a good go to the documents thing. I know, so how do I want to say this? You can connect Power BI to so many things that I'm sure there's a way, but normally I'm producing this output through data frames. And I guess I'm going to say it is possible. I just can't tell you exactly how that works.
It's like the C# programming language. You can connect it to probably anything you want it to, but you're going to have to Google some weird stuff to figure that out.
And I'm not an expert in Power BI. That's why I'm hesitating here. But there's so many connectors to Power BI that I can't even keep track of it, right?
Okay. Yeah, that makes sense.
Yeah.
All right, thank you.
Okay. So so globally distributed means I'm not just going to get 3 copies that I get to choose, like some things. I'm not just saying, yes, make this geo-redundant. I get to actually pick the places that I want my database to be globally distributed. So unlike traditional relational databases, so DB2, Oracle, SQL Server, all the others, this was architected to be distributed, highly, highly distributed anywhere on the planet. It can fail over, and you can have multi-regional rights. So you're having active databases on the other side of the planet, and it can manage those rights. And we're going to talk about that in a minute. Low latency. So this is one of the first products I've ever worked with a database that has guaranteed latency. You can get read latencies of less than 10 milliseconds, depending on how much you want to pay and how you configure it. Write latencies of less than 15 milliseconds. And it all depends on how you configure it, how you cost it, how you set it up to spend. And if the SLAs aren't met, you get money back. Now, I'm only going to talk about these special units of measures with Cosmos DB. One of the things that's different, if your license, your storage, well, storage is a little bit different. If you're licensing, your compute, your networking, your data movement, your notebooks are all included in the price of something. How do they do that? Well, the way Microsoft does for most of these services is it creates a special defined unit of measure. So in the case of Cosmos DB, it's called a request unit. This manages all the resources. It measures all the resources for reads and writes and compute for all the things it's doing in Cosmos DB. And you specify how many request units you're willing to spend at any one time on your Cosmos DB. And it's a lot more complicated than this, but it really is a pricing unit that's an abstraction of all of those things that we used to price separately. And you can provision resources based on it. So for instance, if it's, a very important, highly performant, mission critical, you're going to lose $1 million a minute. If it's not performing well, then you can say, go spend $500,000 a minute. Like, that's way out of line, but in that example. And so request units are both how you're billed for things and how you provision it. So you don't say, I want a server with this much memory and this kind of compute. You specify the request units and it says, let me go off and get you the best performance I can get you with that budget. So the global distribution with Cosmos DB, which is, of course, is one of the cost factors that causes your request units to go up. Cosmos DB is distributed. You get high availability within the region that you provision it. So if you only say, please make me a Cosmos DB in Canada East or Canada Central, it will just go out and provision it there, and you get high availability within that region automatically. If you distribute it across regions, then you'll survive a regional outage. You also can get those guaranteed latencies and high availability and automatic disaster recovery. That means that if one of your copies of your database goes down, it will just automatically fail over to the database that is available. We're not going to go into the details of partitioning in Cosmos DB because that's another hour-long thing. But the only thing I want you to take back for this is choosing a partition key for Cosmos DB is the most important thing you will ever do in designing the database in managing performance and costs. And this has to do with how compute applies to the data as it's partitioned. And it's so important that you have to know the name of your partition key, how it's spelled at the time you provision an empty database. And you can't change it because it's a physical part of Cosmos DB. If you need to change your partition key, you need to rebuild your database with a different partition key and then switch over to that, which could, cause a slight outage. And also you would need to test all of your application code and everything to see how it performs with the different partition key. Now, the trade-off with highly distributed data is you have consistency trade-offs. So the CAT theorem. Cosmos DB comes with these tunable consistency levels. They look like they're a continuum, but they're not really. So strong consistency means Cosmos DB works just like a relational database. You write 3 copies you have distributed your data in 3 different places, and you write data to it. The database isn't going to consider that write completed until every copy reports back, yes, the data is written. So that's how relational databases work, because we want transactional systems to be highly consistent. Bounded staleness says, I don't really need strong consistency, but I don't want anyone to see data that is more than 2 minutes out of date or more than 100 items out of date. This means that not all copies need to be written before the transaction is complete, but within this either time frame or item frame, I'm going to bound how stale any individual query might bring back data. The next one is session. Session is, I need to write data. I don't need strong consistency. But if Karen, write the data and then query it right away, I want to ensure that I see the data I just wrote. So that's session consistency. The next one is consistent prefix, which is a little bit more, it has to do with what order data comes back in, and that that data could be shown out of order and it will be stale. And then eventual consistency is what every NoSQL database loves, is eventually all the data will be consistent. And therefore, any one person querying data can see data out of order, could see data that's stale, and at some point, which is usually just a very short period of time, we're not talking minutes or days, everyone will see all of the data eventually. The reason this is important and different than a lot of different databases is you often set consistency level by how many nodes have to be consistent instead of these special use cases. So were there any questions about Cosmos DB?
We don't have any questions coming in yet, but I think people are still digesting.
Yeah, that's fine. And Cosmos DB is really exciting for me because it was built to be globally distributed, highly available, and it's multi-model. Because I grew up with pre-relational, then relational databases. But I think being able to use a database engine that is optimized to do certain types of data stories, like a graph query and graph data that's highly about its relationships to each other, it's sometimes really important to use graph structure and processing against data when relational doesn't perform as well and it's harder to develop against. And the same thing goes for key value, all of those other NoSQL forms of things. Now, the one thing I want to say about Cosmos DB is it has clusters of clusters. And anytime the word clusters or multiple nodes comes up, you need to know it has a high cost, because a cluster is a series of compute, and compute is the most expensive thing in the cloud, like literally paying for virtual machines to do their stuff. And with clusters, there could be 60 of these machines running every hour. That's a lot. So I'm going to go quickly through the relational database stuff because
before we slip into that, we do have a question. Does Azure Cloud support other NoSQL databases? So I guess it's an elaboration on that.
Yeah, I know. So I'm trying to think of how to answer. So it all depends on what you need. Yes, there's Azure MySQL, there's Azure now. I think there's other NoSQL databases that are offered as an Azure software as a service or a database as a service for sure. I haven't included them here because they're not part of the core data platform certification, which is where my materials are inspired by. But there's that. And then, of course, there's always that you can spin up a VM, install your own database, manage the database yourself. Like that's always an option. And there are many, many NoSQLs that you can load up and do that with.
Okay, so that part is good to know.
Yeah, yeah. So relational databases. So the big one is Azure SQL Database. This has had like 20 names. Okay, I'm being facetious. This has had maybe 6 names since it started, but it is basically SQL Server as a database as a service. They call it a platform as a service. I think of it as a database of a service. When it first came out, it had very few features. It had very small databases. And now it has very high feature parity to your on-prem SQL Server database engine. The only things that are missing are things you can't manage in software as a service. So you can't say, please stripe my data across these 15 files. Please install it on the C drive. Please do these things under the covers. So all the physical part of managing SQL Server is managed by Microsoft, and therefore you can't go in and configure or tune those things. The other thing that has been different is that Microsoft has taken cloud-first development for many of their offerings, but specifically for SQL Server, so that if they're thinking about a new feature, they put it in Azure SQL DB first, and then eventually, once they get feedback and telemetry about that and how it's being used, then they port it to the on-prem SQL Server product. Microsoft handles all the upgrades and patching. It has good availability and it's scalable, but not in the same sense as all other things are. Like you can spend more request units, database units on it, or scale it up to a higher vCore. So it scales differently than some of the things we've talked about before. There are 3 types of things. You can do a managed instance. It looks like you're on a dedicated server. I mean, you are on a dedicated compute and storage. It does allow you to do some more physical things. You have private IPs, so that's that. There's single database deployment. I do a lot of single database deployments because I'm just playing with features and I don't need the next thing, elastic pools. And I have some slides for what elastic pools are. The other thing is that when it first was deployed, Azure SQL had database throughput units, again, a made up metric that combines all the compute, memory, reads, and writes, and with service tiers, but you had to specify the DTUs per database server, kind of. Then they introduced vCores, which allowed you to choose a specific level of compute. And it also has service tiers, and you can do that for single or pooled databases. An elastic pool is that it allows you to configure resources for multiple databases, and it allows you to respond to differing blippy workloads across those databases. And it means that your databases in a pool are sharing server resources. So in a single database, I would provision either DTUs or vCores for every single database. So I might have a small database that I give very few DTUs to, and a larger one, which also has more workload on it, I might give it more. But if any one of these databases exceeded those needs, it would be throttled. So your database still works, but it gets throttled because you said, please only use this amount of DTU or only use this amount of compute core. With an elastic pool, you specify all the DTUs and all the vCores that all the databases can use, and therefore you're doing less management of DTUs and vCores. eDTUs that do this, they cost a little bit more because they're shared, but it's an option so that you can let the cloud manage your workloads. So that was SQL Server. Azure Synapse Analytics, which is the other relational offering in Data Platform, this recently got rebranded. So we used to have Azure SQL DB and Azure Data Warehouse. Azure Data Warehouse is now a part of Azure Synapse Analytics, which is a framework. This is a product and branding name, a rebranding, and a collection of all the parts you need to do very big data analytics. And it includes things like machine learning, Cosmos DB uses, the storage, the Azure Data Warehouse, which is now called Azure SQL Dedicated Pools, pipelines, and Apache Spark. It really is the name of a collection of Azure technologies. But people still call Azure Data Warehouse Azure Synapse. But that particular feature is called Dedicated Pools. And the way it works is you have a query coming in, it comes into something, this control node, and that has this data movement service. It goes through this massively parallel compute engine and distributes the query to the compute nodes that also have data that is stored on Azure Storage. But in those compute nodes have the relational data, a copy of the relational database engine on each compute node. That's a lot. The keywords here are, it is designed, it looks and feels just like SQL Server. When I log in with SQL Server Management Studio, it looks just like a SQL Server database, any other one, But behind the scenes architecture is completely different because it's this parallel compute. When you provision a dedicated pool, you get up to 60 nodes of compute, depending on what service level you do. And it's all premium storage, which means it's highly performant storage. You pay for all of the storage, even when the dedicated pool is paused. This is one of the ways. So I said, anytime you see clusters or mini compute nodes, things are expensive. But one of the things you can do with dedicated pools, formerly Azure Data Warehouse, is say, do something like pause it on the weekends or pause it on the evening or pause it for 2 hours. You can save money by automatically pausing the compute so that you're not getting billed for it. So data distribution on a pool is one of the things, is not only is your compute spread out across these nodes, but rows of data can be distributed across many nodes. And there are 3 algorithms for this, and it all depends on what you're optimizing for. So this is physical distribution of your data. And so you want to avoid hotspots, just like any other distribution or partitioning scheme. There's hash distributed. It means that, I have pictures of this coming up, so we'll do this. Round robin means the data is distributed randomly. And the reason you might want to do this is for something like a staging table or to optimize your loading time. Whereas hash distributed, you want to improve your query performance. So it all depends on what you're optimizing. And then replicated tables are really for reference data, like a list of country codes. It's small data sets. It increases performance and storage costs a bit because that data is sent to every node, not just distributed, but sent to every node. So in round robin, this a distribution key that has the same value might get sent to different nodes. And that's why it's optimized for load performance, because it's not having to go find where the data is. It's just saying randomly write this data to all the nodes. Hash distributed means a hash key with the same value goes to the same node. One of the things is your distribution type model. In this case, you can't change that value. With what you do is you add a new row and delete the old one. And that's because it has to physically go rewrite that data. Replicated tables, like I said, good for master data, product lists, state and country codes, all your quote lookup tables. And this makes compute go fast because that data appears in every node. It doesn't have to go move data into a node in order to satisfy that. So Azure Synapse Analytics, much bigger than what I've talked about. The most important thing is it appears to an end user that it is SQL Server, just like any other SQL Server, but it's completely different under the covers. Like with SQL Server or Azure SQL DB, you don't have 60 compute nodes that are doing massively parallel processing. So were there any questions about Synapse?
So I don't think there are any questions about Synapse yet, but we do have some questions from a bit earlier.
Okay.
We're definitely on a roll with this section, and I think as we ask these, other questions might come in.
Sure.
We are approaching time.
Yeah, I know.
But yeah, so the first question we have is, what happens if data loading stops and one of the bounded stateless rules fail?
Oh, that's from Cosmos DB.
Yeah.
So the consistency levels really apply at the time data is written, and you've given Cosmos DB, here are the rules for considering this data has written successfully. If the data doesn't meet those rules, then that's an error, right? I hope that answers that.
Yeah. The sort of second half of that was, does it clean data that has already been written? And I guess if it's been considered written,
if it unsuccessfully, it's like there are transactions in Cosmos DB because not all data writes are singular like that. You know, you're writing, like the issue is in a relational database where it's all strong consistency. If you have foreign keys, is you don't want to write an invoice header and then only half the lines. You would normally wrap that all in a transaction and roll it back. The consistency models is just how Cosmos DB says, yes, this is written well enough that I can go on to processing.
Okay.
Okay.
I hope that answers the question for the chat. We also have, can you talk a bit about dedicated versus serverless SQL pools?
See, now we're getting down into the details that I can't really do. A lot of the offerings in Azure now have these different forms, whether it's managed instances, serverless, like those are sort of advanced topics that I would refer you to the documentation. This is a fairly new offering for those, but it basically means that you are managing less of what you did if you did the traditional deployment, because Microsoft's doing more of it.
Mm-hmm. Okay, interesting. Yeah, I think that is a bit more, you can get more technical depending on how much of an answer you want.
Yeah, okay. Stream Analytics, so I'll go through this one quickly. So Azure Stream Analytics is just that. It's an analytical platform, ASA, that you specify inputs, queries, and outputs. It uses Event Hubs or Iot Hubs. So this is a common streaming thing. So I mentioned with Databricks, it does streaming, but that's because it's built, that streaming is built into the overall Databricks offering in the open source project. Azure Streaming Solution is a Microsoft product, 100% Microsoft service. And you basically have hubs that collect streaming data and send it through analytics. So in one example, I have these devices out in the field. Because they're IoT, the IoT hub is processing them. The 1001 there is Azure Blob Storage. I might also have applications that are running that are sending events to an event hub. That all gets managed and orchestrated and written to Blob Storage. And then I can read it either directly from the hubs or Blob Storage to do streaming analytics, maybe do some machine learning, and then write it to a whole bunch of target potential solutions for it. So the way it works, I have publishers, they produce events, those events go to a hub, the hub collects them and deals with them, and then sends the stream to all of those providers. And there's all kinds of ways that you have to tune these things. It also has a partitioning strategy, but we won't be going into that. IoT hubs are a special type of event hub that, because it's IoT, there's bi-directional. A regular event hub just consumes data and passes it along. An IoT hub consumes data, but can also send messages back to the device. It can be scaled to millions of devices. Of course, it has tiered performance and pricing, and it has 3 nines of availability. So the biggest difference is the technologies they can support. And I don't work with a lot of these technologies, but understanding that there's an event hub specifically for IoT that writes in both directions, and as well as event hub that does all kinds of streaming messages. So I can write those outputs to relational data stores, non-relational ones, a service bus, other event hubs, Azure functions, which are a way of automating things. There's a lot of that going on. Azure Data Factory is my favorite to play with because I like ETL tools or ELT tools, depending on what it is. So in this example, I have a movies DB. This comes from one of the how-tos in the documentation. So I have a movies database and I send it to a pipeline, and the pipeline imports the data into Azure Data Factory. It finds, in this particular example, the data has ratings on movies. It has 2 ratings. It has one for Rotten Tomato, and it has one from, professional reviewers. And then I wrote this Azure Data Factory where I had a query that said, show me all the places where either the pros thought that the movie was better than the crowds or vice versa. And then I also aggregate them by genre to see the mismatch ratings. And then I also export a file that just has the movies with the mismatched ratings. And I also do it average. And those get written to 2 different blob stores. And of course, there's a whole lot more you can do with it because you have data sources and services. You define a pipeline, you can use it multiple times, and it all on the underside gets stored as JSON, so you can plug it into any automation or any of your repositories or anything like that. I'm going to skip that one. The concept of a sink is just the target data store. So it's the end of an Azure Data Factory pipeline. You can read from a bazillion sources, but you're more limited on what you can write to. And it has the concept of integration runtimes, which does all the processing. And to save money, to save your Azure bill, you can have your integration runtime run in the cloud as a managed service, or you can run it on-prem. And that's really cool for when you need to connect to databases that are on-prem, connect to the integration runtime, and then write it all to the cloud in Azure Data Factory. And you can do all kinds of transformations in it using any of the Hadoop stack or machine learning, custom code, or Databricks, any of those things. And this would be a good way to get Databricks to write to Synapse or any of those other things by using Azure Data Factory. And of course, it has control-like programming stuff. There's my flow again. And then it can run on triggers based on time, based on a tumbling window, responding to an event like a file got put in a directory, and you can just run it all on your own. The one last thing is all of these tools over the years have expanded to be having their own native monitoring security features to now Azure has a combined security and monitoring service, which I truly love. And it's just easier to demo that. So I know I'm going to take a couple of minutes. Is that okay? Just to show a few things.
I think we're good with a couple more minutes. Yeah.
Okay. So where am I? So in Security Center, these are all my demo stuff in my subscriptions. You can see I have some unhealthy resources. Only 83% of my things or whatever I have in the subscriptions are covered by Azure Defender. I have all of these regulatory compliance things that I'm not meeting. My favorite part of all this is recommendations. So you can see that for whatever, only 89% secure score, but I can go down and get individual tests. And see, I don't have Azure Defender for SQL enabled on my servers. Oh, I do have it done, so that's good. I'm not securely encrypting data in transit for all my storage accounts. I have external accounts that have permission to my subscriptions. I haven't enabled auditing or my key vault. Like, one of the great things about all of this monitoring stuff is not only does it highlight security things, but it can give you a quick fix, including a script to run on my specific things that I could go run now to fix this security hole. And of course, you shouldn't do that blindly, but those are some of the things. So I wish I could have demoed more about Monitor. I mean, part of Azure Defender for SQL is it will go through and look at all my table and column names and guess about which ones have PII, financial data, and suggest I apply certain security measures to it. and it's specifically looking at names of my tables. So if you have good column names and table names, it's good at guessing in multiple languages. That's one of the things. And then I said, I wanted to tell you how to get free access. So there's two major ways. One, you can get 12 months of, that's a whole year of popular free services that are limited just for learning, not really good for production use. You can do a one-time sign up to get $200, this is Canadian, for 30 days to spend any way you want. So playing with storage and maybe a test database, good. Spinning up an Azure Synapse cluster, not going to last an hour. And then there are 25 services there. And this 30-day thing is a one-time deal per email address. But here are the products that are totally free. You can get 750 hours of a Windows virtual machine, 5 gigabytes of blob storage, file storage, a 250 gigabyte SQL database, 400 request units of Azure Cosmos DB, and there's more under here. So I would recommend a combination of playing and learning with all the products that are free for a year, as well as once you've done that for a while, signing up for the $200 credit so that you can do something a little bit more in depth. The other way to get free Azure credits is if you have an MSDN subscription, your company is a Microsoft partner, those all get you free credits as well. There are also coding challenges that are available. So right now, virtual training days in Canada that are coming up, they're all free for working with a lot of the Azure features. And sometimes these training events also award free credits or a sponsored subscription. So that's good to know about. I also want to point out.
So, sorry.
Yeah.
So, it'd be great to publish these URLs, you know, link below, and we'll do that after our session.
Yeah, I would do that for sure. You can get certified in all kinds of Microsoft things. I happen to be this Azure data engineer. And you get a certificate and a badge and all that good stuff. Let's see. I think that's all I had. Let me go back.
I think that's a lot. I wouldn't blame you if you didn't have any more.
What I have is a thank you screen. Anyway, so I would love to tweet with you, Facebook with you, LinkedIn with you, and also my website has some other resources for people, mostly focused on data management, but there's a lot of Microsoft stuff in there as well.
Well, that's awesome. Thank you so much for this. This has been very interesting. The questions we really have now are all about, you know, what are the subscriptions? What are the options to sign up and get access to these services? And you saved that right for the end. And like Deborah mentioned, we'll also find some of the links directly to these resources so folks can check it out directly. But yeah, thank you so much. This has been really interesting.
I know it was a lot and it was really fast, but
yeah.
Well, we'll see if we can convince Karen to come back again.
Yeah,
absolutely. That would be fantastic.
Yeah, for sure.
Yeah. But yeah, thank you very much. And thank you everyone who came out to attend. Deborah, you got any final words for folks or?
No, it's just been, you know, a lot of information, but it's been really a great learning experience. So thank you, Karen.
Yeah. Thank you. Thank you, Karen. Thank you everyone who came out to join. Everyone, I hope you get a chance to play with this stuff, and thank Karen by talking about data with her.
And we'll see you next month.
We will see you next month. Yeah. Thank you all.
Thank you, everybody.
Yeah.
Bye for now.